Welcome to the virology sections of the GIFRA 2021 second day. Today I would like to introduce my colleague Dr. Teresa de los Santos, who will introduce the topic of our session in virology. Teresa?
Yeah, thank you, Elizabeth. Good day, everybody. And thank you for being here today in this section. So, as most of you know, replication of FMD proceeds at a rate that outcompetes the ability of the afflicted host to respond against infection. To achieve this high rate of infection, the virus must quickly establish replication factories within the cell and shut off many intracellular antiviral responses. This remarkable and complete takeover of the host replication and translation machineries require that this small and genetically simple virus utilize multiple viral and cellular proteins as well as subcellular structures to optimize its replication and spread. Over the years, a group of people at Plum Island, where I work, and other researchers in the field have accumulated a lot of information on this regard, highlighting for once on the genomic RNA front, on the importance of RNA structures, cis and transactivating elements in the two untranslated regions of the genome, and second, the fact that codon or codon pair bias usage may play a role in virulence. At the same time, and perhaps at even higher rate, we are learning now very quickly how viruses, including FMDB, triggers innate immune responses in the host, and which are the mechanisms evolved by the virus to effectively counteract these responses. Indeed, and fortunately or unfortunately, the COVID-19 pandemic has set a historical mark in virology, accelerating this type of research across most virus families. As you've just heard in Dr. Zeng's seminar, we now know that FMDB uses not only its genomic nucleic acid, but basically all its proteins to counteract innate responses. Perhaps the most studied elements, as I mentioned before, are the 5' and 3' UTR of the viral genome and the protein leader protease. But as Dr. Zeng mentioned, basically all the VPs, the structural proteins, and at least the non-structurals 2B, 2C, 3A, 3B, 3C, and 3D have roles on counteracting host defenses. Further, many of these proteins have multiple ways of exerting their function, as demonstrated mostly in the proteins that have enzymatic activities, as, for example, leader, 2B, 3C, and very importantly, 3D. And even more, and very interestingly, the structural BP3 protein have also shown many activities, despite the lack of an enzymatic activity. We could then definitely say that FMDB uses genetic economy, or it is a significantly versatile virus. Our speakers in the virology session today will touch upon many aspects of these complex interactions, and following their presentations, we will host a roundtable discussion. Please feel free to post questions in the Q and answer tab in a window. Elizabeth?
Thank you, Teresa, for the introduction. Our invited speaker is Dr. Giselle Medina. Dr. Medina obtained her PhD from the Molecular Genetics and Microbiology Department at Stony Brook University in New York. She followed with the postdoctoral trainings at both the NIH and also at Plum Island Animal Disease Center. Dr. Medina has recently joined Plum Island Animal Disease Center as a principal investigator, a research molecular biologist, and soon this laboratory will move into the National Bio and Agro Defense Facility at Manhattan, Kansas, in the near future. Giselle Medina's research focuses on understanding the dynamic of virus-host interactions with the ultimate goal to improving vaccines or biotherapeutics intervention. The focus of her presentation today, and the title is Understanding the Attenuation of FNDV codon pair de-optimized viruses. Followed by following her presentation, we'll reserve the questions for the roundtable, but following the presentation, we'll have 4 interesting presentations given on the following topics. The first is the frequent interserotypic recombination of foot and mouth disease due to subclinical co-infection with serotypes O and A viruses. The second presentation focused on MDA5 cleavage by the leader proteinase of FNDV, reveals its pleiotropic effect against the host antiviral responses. The third presentation is on mutagenesis mapping of RNA structure within the FNDV genome, reveals functional elements localized in the 3D polymerase encoding region. And our final presentation would be on RNA secondary structure in the FNDV virus genome, shields the virus from sensing by SAP. So with that, Giselle, the stage is yours.